Hello and welcome back to Science in the Silence. I forgot to mention this in my previous video, but remember to like and subscribe if you like what you're seeing here. Okay, so today we're going to have a look at mutations. So we're going to have a look at how they work and what their effect is. Okay, so the important thing to remember is that mutations are a change in the base sequence. Okay, so that base sequence on DNA changes. It may be longer, it may be shorter, or the order of bases may be different. Okay, so that can then have two possible effects on the protein. So we'll have a look at those two effects now. So if we move this up, let's have a look. So the change in the base sequence then can cause two effects on the protein. One is to change the number of amino acids in the protein. And the other thing that it could do as well is to change the sequence or the order of those amino acids. So change the sequence of amino acids. Okay. So if you remember how DNA works, the code on DNA is read in codons, which are 3 bases. Okay, so every 3 bases forms a codon, and there are 64 possible codons. So those are the combinations of 3 separate bases that you can possibly make out of all of the bases that there are. There only being 4 types. But there are only 20 amino acids on Earth that we know of. So that means that there are more codons than there are amino acids. So we can have more than one codon for every amino acid. Okay, so if we change the codon, sometimes it means that we're coding for a different amino acid, but sometimes it means that the amino acid that is coded for is exactly the same. Okay, so let's have a look at how these mutations work. So here's our base sequence. Let's take a different colour here. So we'll go with ATC, CAG. So these are the bases on DNA. Notice I'm writing them in groups of 3 because I'm keeping them in their codons. And then each one of these is going to code for an amino acid. Okay, so this is how we make proteins. So there's a blue amino acid, and this one codes for a red amino acid, and this one codes for a green amino acid, for example. Okay, so we can see that if we've got different base sequence, we can have different amino acids, and then these amino acids are joined together by the ribosome to make a protein. Now we have a chain of amino acids. We have 1, 2, 3 amino acids here. They're joined together, so that is now a protein. Okay, so that all happens at the ribosome. But if that goes wrong, if we have a mutation, then that base sequence changes, okay? And we have possibly different amino acids joined together to make a different protein. So the 3 possibilities then for mutations are addition mutations, where you add a new base, deletion mutations, where delete that, where one of the bases is deleted, and substitution mutations, where one of the bases is swapped or changed for another base. Okay, so let's go back and look at that original base sequence that we had, and we'll have a look at how it might change. So here is the original base sequence that we had. So we had ATC, if I remember, CAG and GCC. Okay, so we're going to look at how, to start with, how an addition mutation might work. So let's make that a little bit smaller and move it across. If I add a new base, so let's say that I add a G here, for example. Now the way that we read these codons is going to be slightly different, because now this is going to be a codon, and this is going to be a codon, and this is going to be a codon. Okay, so now we still have a protein, which has 3 amino acids, but those amino acids now could be different because the codons, the letters in their codons, the bases in their codons have changed. So when we get that change in the way that these codons are read, that is called frame shift. Okay, so in this case we were looking at an addition mutation, and the addition mutation can give us frame shift, and frame shift can mean that we might or might not, but we might have different sequence of amino acids joined together to make our protein, and therefore a different protein. So this one has an effect on the proteins. Okay, so let's go back to our original sequence, and this time we're going to delete a base from it. So we're going to look at a deletion mutation. So this time let's say that we have a T and a C, because we've got rid of that original A, and then we still have the remaining bases as they were before. So what happens now when we go to read these codons? Now this is our first codon and this is our second codon, but this third codon doesn't do anything. There's only 2 bases, it's not a codon, so it isn't classed as a codon. It can't code for an amino acid. So what does that mean about our protein? It means that now that this protein only has 2 amino acids, which may be different to the previous ones. So what happens now when we go to read these codons? Now this is our first codon and this is our second codon, but this third codon doesn't do anything. There's only 2 bases, it's not a codon, so it isn't classed as a codon. It can't code for an amino acid. So what does that mean about our protein? It means that now that this protein only has 2 amino acids, which may be different to the previous ones. So our protein is now shorter and has a different sequence, possibly, of amino acids in its chain. So it's a different protein. It has a very profound effect, this one. So we've definitely got frame shift here. Okay, so this is frame shift when the codons are read in a different way, and we've only got 2 amino acids. Okay, so we can see here that deletion mutations have quite a severe effect on the protein. So that leaves us now just with substitution mutations. So let's have a look at how a substitution mutation would work. Let's get rid of that page. Okay, so we go back to our original sequence. So that was A, T, C, C, A, G, and G, C, C. So what happens in a substitution mutation? Well, the first thing is we need to get rid of one of these bases. So let's take this C out. Let's change the base that we're attacking. We take the C out, and now if we replace it with a new base, let's put another A in, for example. Okay. So now the way we read the codons is exactly the same. There's no frame shift here because we still have 3 codons. We don't have any extra bases. The number of bases are exactly the same. But now we've got the possibility where we might code for a different amino acid than we did previously. It's possible. It's not definite. It's possible. But the chances of it changing the protein, either the sequence of amino acids in the protein, is much more limited than in the previous 2 cases. So substitution mutations give us no frame shift. They're rather boring. They could have some effect, but the likelihood, the possibility of having those effects is much less than with the other types of mutations. Okay, so let's just quickly summarize the vocabulary that I think you should take away from today's video. So we'll put it in blue. Here we go. We should have mutation. We should have codon. All of these terms, you need to know them inside out. Base sequence. What else? Amino acid. Over here, addition. excuse my writing. Deletion. Oops. Let's just erase that. That was a silly mistake. Frame shift. Frame shift. And that is it. Okay, hope you enjoyed today's video. Remember, like and subscribe if you like what you see in here, and hopefully I'll be able to get some more on their way very soon. Okay, bye bye for now.